Hello, in this lecture we'll find out the length of line segment X. In the drawing we have two quarter circles. Those two quarter circles, the two quarter circles are tangent to each other at point B. In addition, we know that line segment AB equals to 1 unit. We also know that line segment QS equals to line segment SP, and this is line segment BC is equal to X, and our mission is to find out the length of line segment BC that is equal to X. Okay, so first of all, we know that PAB is a quarter circle. Therefore, AB is the radius of the quarter circle, and PA is also the radius of the quarter circle. That is to say, the radius PA equals to 1 unit, because AB equals to 1. So PA equals to 1. The same thing is true in the bigger quarter circle. BC is the radius of the big quarter circle, and QC is also the radius, therefore it is also equals to X. We will join points P and B together by a straight line. So we have here the right triangle, triangle PAB. In the right triangle, triangle PAB, according to the Pythagoras theorem, PA square equals to PB square equals to PA square plus PB square. So I'll copy the right triangle PAB in the new page and we implement the Pythagoras theorem in the right triangle, triangle PAB. Here by PT is a relation for Pythagoras theorem. So this is the right triangle PAB that occurs from the original drawing. According to the Pythagoras theorem, in this right triangle, triangle PAB, PB square equals to PA square plus AB square. So PB square, that is the square of the hypotenuse, equals to PA square. PA is 1, therefore PA square is 1 square, that is 1, plus AB square. AB square, AB is 1, so AB square is 1 square, that is 1. So in total, PB square equals to 1 plus 1, that is 2. PB square equals to 2. We take a root out of this equation, and finally we will get that PB, the hypotenuse PB equals to the square root of 2 units in its length. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides we have two equal angles. So if this angle is alpha, then the other angle must be also equal to alpha. In the right triangle, triangle PAB, the sum of the angles must be equal to 180 degrees. So alpha plus alpha, that is 2 alpha, plus 90 degrees, must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. We subtract 90 degrees from this equation, and finally we get that 2 alpha equals to 180 degrees minus 90 degrees, it is 90 degrees. We divide this equation by 2 and we get that alpha equals to 90 degrees over 2, that is 45 degrees. So this angle alpha equals to 45 degrees. Then the angle alpha equals to 45 degrees in its size. So we can write in the original drawing that this angle alpha equals to 45 degrees. This is also angle alpha that is equal to 45 degrees. We'll join points Q and B together by straight line. By joining points Q and B, we created the right triangle, triangle QCB. So I'll copy the right triangle QCB in the new page and we'll implement the Pythagoras theorem on this right triangle, triangle QCB. Again, by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle QCB that I got it from the original drawing. According to the Pythagoras theorem, in the right triangle, triangle QCB, QB squared, that is the square of the hypotenuse, must be equal to QC square plus BC square. So QB square equals to QC square. QC is x, therefore QC square is x square plus BC square. BC is also x, therefore BC square is x square. So in total, QB square equals to x plus x, that is 2x square. Again, QB square equals to x square plus x square, that is 2x square. Here we take a root out of this equation, and finally we get that QB, that is the length of the hypotenuse in the right triangle QCB, QB equals to the square root of 2x square. So QB equals to the square root of 2, and the square root of x square is x. So in total, QB equals to square root of 2 times x. So write it down. QB the hypotenuse QB equals to the square root of 2 times x units in its length. So here we already found out that those two angles, each of them is equal to 45 degrees. And here also those two angles, we have the same rule that in front of equal sides in the triangle there are equal angles, so those two angles are equal to each other. So I will not repeat on the same process. So those two angles that are equal to each other, in total they must be equal to 90 degrees, because this angle equals to 90 degrees. So those two angles in total they are equal to 90 degrees and they are equal to each other. Therefore each angle must be equal to 45 degrees in its size. next step, I present to you rule number 3, and we'll implement rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So we have in the drawing the straight line AB. If you focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of AB at point Q? We have this angle alpha and angle beta. So in total, alpha plus beta must be equal to 180 degrees. We can implement rule number 3 in our drawing. Why? Because in our drawing, we have the straight line AC. If you focus on the upper side of the straight line AC at point B, here the sum of the angles must be equal to 180 degrees according to rule number 3. So I will draw the straight line AC. Again, the sum of the angles on the upper side of the straight line AC at point B must be equal to 180 degrees according to rule number 3. So according to the straight line AC, here, again, the sum of the angles on the upper side of the straight line AC at point B must be equal to 180 degrees according to rule number 3. So which angles we have? Which angles we have at the upper side of AC at point B? We have this angle is equal to 45 degrees plus the missing angle that we define as X plus 45 degrees. In total, it must be equal to 180 degrees according to rule number 3. 45 degrees plus 45 degrees is 90 degrees, so 90 degrees plus x must be equal to 180 degrees. Here we subtract 90 degrees from this equation, and finally we get that the missing angle x must be equal to 180 degrees minus 90 degrees, that is 90 degrees. So the missing angle is a right angle. So here you can write down that the missing angle PBQ, it is a right angle, it is equal to 90 degrees in its size. And therefore, actually, triangle QBP is a right angle. Okay? Triangle QBP is a right angle. In the next step, we will draw a circle around the right triangle, PBQ. We have the rule that any triangle can be blocked by a circle, therefore we can definitely block the right triangle PBQ by a circle. So we'll do it now. So this is the right triangle PBQ that are blocked by a circle. So in the drawing we have peripheral angle PBQ that is equal to 90 degrees, and we have rule number 5 that relates to a peripheral angle that is equal to 90 degrees. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. In the drawing we have a circle. Inside the circle we have peripheral angle MAN. This peripheral angle MAN is equal to 90 degrees in its size. And therefore, according to this rule number 5, this peripheral angle MAN must rest on the diameter of the circle. From the drawing it is very easy to see that peripheral angle MAN rests on chord MN, and therefore chord MN must be the diameter of the circle. And indeed, you can see from the drawing that chord MN is the diameter of the circle. Why? Because it passes through point O, that is the center of the circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. So in conclusion, you can say that because of the fact that peripheral angle MAN is equal to 90 degrees in size, therefore this peripheral angle MAN rests on the diameter of the circle. That is to say, MN is the diameter of the circle. We can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle QBP is equal to 90 degrees in its size. Therefore, according to rule number 5, this peripheral angle QBP again, peripheral angle QBP equals to 90 degrees in its size. Therefore, according to rule number 5, peripheral angle QBP rests on the diameter of the circle. From the drawing it is very easy to see that peripheral angle QBP rests on chord QP. Therefore, chord QP must be the diameter of the circle. So I can write here that according to rule number 5, chord QP is the diameter of the circle. Okay, chord QP is the diameter of the circle. So here, QP is the diameter of the circle. And we know that PS equals to SQ. Here, this is point S. It is given us the question that PS equals to PQ. So if we define PS as X, then SQ must be also equal to X. So we know that QP is the diameter of the circle. So if we define the radius of this circle as X, then if we define the radius of this circle as R, then the diameter QP must be equal to 2R. So from one side, the diameter QP equals to 2R. From the other side, it is equals to 2X. Again, the diameter QP equals to 2R. From one side, from the other side, QP equals to 2X. Therefore, from those two equations, we derive that 2R equals to 2X. We divide this equation by 2 and we get that X equals to R. That is to say, PS is the radius of the circle that is equal to R, and SQ is also the radius of the circle that is also equals to R. Okay? So PS is the radius of the circle that is equal to R, and SQ is also the radius of this circle that is equal to R. So point S must be the center of the circle. Okay? Here, the two radii touch each other at point S. Therefore, point S must be the center of the circle. We join points S and B together by a straight line. Point S is the center of the circle, point B is the point of the circle itself, therefore SB is also the radius of this circle that is equal to R. So all the three line segments PS, SQ and SB, they are all the radii of this circle that is equal to R. Okay, so here we join points S and B together, found out that SB is the radius of this circle that is equal to R. And PS is also the radius of the circle that is equal to R, and SQ also equals to R. Okay. So here, in triangle BSQ, those two sides are equal to each other. Therefore, it is an isosceles triangle. But before that, we will do a construction. That is to say, we will complete the big quarter circle QCB to a circle. Okay. Point C is the center of the circle. This angle QCB equals to 90 degrees in its size. This is a right angle. repeat again. We completed the big quarter circle to a circle. Here we have peripheral angle BSQ that subtend on arc BQ, and we have the central angle BCQ also subtend on the same arc BQ. And here we have all number 11 and all number 13, that a central angle is twice as large as the peripheral angle subtended on the same arc. So in the drawing we have the peripheral angle ACB. So if the peripheral angle ACB is equals to theta in its size, then the central angle AOB that subtend on the same arc AB must be twice as big, twice as large as the peripheral angle ACB. So if the peripheral angle ACB equals to theta, then the central angle AOB that subtend on the same arc AB must be equal to 2 theta. Okay? We can actually implement rule number 11 in our drawing. Why? Because in our drawing we have the central angle BCQ. This is the central angle BCQ. We know that the sum of the angles around point C must be equal to 360 degrees according to rule number 6. According to rule number 6, the sum of the angles around the point will always add up to 360 degrees. So here the sum of the angles around point A must be equal to 360 degrees. Why? Because we can draw a straight line through point A, and we know that according to rule number 3, the sum of the angles on the upper side of the straight line at point A must be equal to 180 degrees from one side, but from the other side, the sum of the angles in the lower side of the straight line at point A must be also equals to 180 degrees. So in total, the sum of the angles around point A is 180 degrees plus 180 degrees, that is 360 degrees. Okay? So we can actually implement rule number 6 in our drawing. Why? Because according to rule number 6, the sum of the angles around point C must be equal to 360 degrees according to rule number 6. So which angles we have around point C? We have, this is a right angle that is equal to 90 degrees. So this angle must be equal to 360 degrees minus 90 degrees according to rule number 6. So 360 degrees minus 90 degrees, it is 270 degrees. So in total, this angle equals to 270 degrees in its size, and angle BCQ, the central angle BCQ, that is equal to 270 degrees, must be twice as large as the peripheral angle BSQ that subtends on the same chord called BQ. Here, this peripheral angle BSQ subtends on chord BQ, subtends on arc BQ. Therefore, it must be half of the central angle BCQ that subtends on the same arc BQ. So, this angle BSQ, the peripheral angle, must be equal to 270 degrees over 2, that is 135 degrees. Okay? And we have already found out that BS equals to SQ. They are both the radii of the circle, so BS equals to SQ. Here, BS equals to SQ. So in the right triangle BSQ, BS equals to BQ. And we have all the sum of the angles in triangle BSQ in total must be equal to 180 degrees. But here we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides there are two equal angles. So those two angles that are located in front of the equal sides BS and SQ must be equal to each other. So if this angle is alpha, then the other angle must be equal also to alpha. So in the right triangle, in the triangle BSQ, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So 135 degrees plus alpha in total must be equal to 180 degrees. So 135 degrees plus 2 alpha must be equal to 180 degrees. We subtract 135 degrees from this equation, and finally we get that 2 alpha equals to 135 degrees minus 180 degrees minus 135 degrees, it is equals to 45 degrees. So alpha equals to 45 degrees over 2. Okay, so this angle alpha equals to 45 degrees over 2. This is also angle alpha that is equal to 45 degrees over 2. So I can write here that this is angle alpha that is equal to 45 degrees over 2, and this is also angle alpha that is equal to 45 degrees over 2. So we will focus on the right triangle PBQ. So I will copy the right triangle PBQ in a new page, and we will analyze this triangle PBQ. We have already found out that PB equals to the square root of 2 units, and BQ equals to 2 times square root of 2 times x units in its length. And this is angle alpha that is equal to 45 degrees over 2, 45 over 2 degrees. That is actually 22.5 degrees. So actually, this is the right triangle PBQ that I copied from the original drawing. Here, PB equals to the square root of 2 units. So, in the right triangle PBQ, tangents 45 degrees over 2 equals to PB over QB. So, tangents 45 degrees over 2 equals to PB, that is square root of 2, over QB, that is square root of 2x. So, square root of 2 over square root of 2 is 1, so square root of 2 gets cancelled, and this expression equals to in total to 1 over x. So in conclusion, found out that according to equation number 1, tangents 45 degrees over 2 equals to 1 over x. Okay, this is according to equation number 1. We will define 45 degrees over 2 is theta. Theta equals to 45 degrees over 2 degrees, according to our definition. Therefore, 2 theta must be equal to 45 degrees. And we have that trigonometric identity that states that tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. So, theta is 45 degrees over 2, so 2 theta is 45 degrees. So, we substitute 2 theta by 45 degrees, and we get that tangents 2 theta is 45 degrees, and it is equals to 2 times tangents theta. And theta is 45 degrees over 2, so it is 2 times tangents 45 degrees over 2 over 1 minus tangents square theta. So it is tangents square, and theta is 45 degrees over 2. So according to equation number 2, we actually found out that tangents 45 degrees is 1, so 1 equals to 2 times tangents 45 degrees over 1 minus tangents 45 degrees over 2. We will define tangents 45 degrees over 2 as t. Repeat again. According to our definition, tangents 45 degrees over 2 equals to t. Now we can substitute tangents 45 degrees over 2 in this equation number 2 by t. And we get that tangents 45 degrees is 1, that is equals to 2 times 45 degrees over 2. So it is 2 times 45 degrees over 2 is t. So it is 2t over 1 minus tangent square 45 degrees over 2. So if tangent 45 degrees over 2 is t, then tangent square 45 degrees over 2 is t square. So in conclusion, we found out that according to equation number 2, 1 equals to 2t over 1 minus t square. Here we will multiply this equation by 1 minus t square, and you get that according to equation number 2, 1 minus t square equals to 2t. We will add t square to this equation number 2, and we get that 1 equals to 2t plus t square. We subtract 1 from this equation number 2, and finally we get that t square plus 2t minus 1 equals to 0. Okay. So we have here a quadratic equation, t squared plus 2t minus 1 equals to 0. The coefficient a in this quadratic equation equals to 1. The coefficient b equals to 2. And the coefficient c equals to minus 1. And x equals to t. And the solution to the quadratic equation is x equals to minus b plus minus square root of b square minus 4 times ac over 2a. Here a, b and c, this equation is the coefficients of the quadratic equation, and x is the variable that we are looking for. In our specific quadratic equation, x equals to t. So here x equals to t, it is equals to minus b. b is 2, so minus b is minus 2, plus minus square root of b square. b is 2, therefore b square is 2 squared, that is 4, minus 4 times a is 1, times c, that is minus 1, over 2 times a, that is 1. So t equals to minus 2 plus minus square root of 4 minus 4 times minus 1 is plus 4. So it is 4 plus 4, that is 8 over 2. So t equals to minus 2 plus minus 8 is 4 times 2 over over 2. Repeat again. Found out that t equals to minus 2 plus minus square root of 4 times 2 over 2. The square root of 4 is 2, so inside the root we left only with 2. So t equals to minus 2 plus minus 2 times square root of 2 over 2. So t equals to minus 2 over 2 is minus 1, and 2 over 2 is 1. So in total t equals to minus 1 plus square root of 2. So t equals to minus 2 plus minus. So we have here two solutions that are possible for t. The first solution for t is that t equals to minus 1 minus square root of 2. And the second solution for t is that t equals to minus 1 plus square root of 2. According to our definition, t equals to tangent 45 degrees over 2. Repeat again. T equals to tangent 45 degrees over 2. But because of the fact that tangent 45 degrees over 2 is a positive number, so here t is a positive number. Again, t equals to tangent 45 degrees over 2. And tangent 45 degrees over 2 is a positive number. And it cannot be equal to minus 1 minus square root of 2, that is a negative number. Okay? Again, t is tangent 45 degrees over 2. Tangent 45 degrees over 2 is a positive number. Therefore, it cannot be equal to minus 2 minus square root of 2, that is a negative number. So we cancel this solution, and we left only with the other solution that is possible for t, that t equals to minus 2 plus square root of 2. T is tangent 45 degrees over 2, and it is equals to square root of 2 minus 1. Okay, that is from one side, but from the other side we already found out that tangent, this is according to equation number 2, according to equation number 1, we have already found out that tangent 45 degrees over 2 is equals to 1 over x. Okay, so we have here two equations. According to equation number 1, tangent 45 degrees over 2 equals to 1 over x, while according to equation number 2, tangent 45 degrees over 2 equals to the square root of 2 minus 1. Okay, so from equation number 1 and equation number 2, we will derive that square root of 2 minus 1 equals to 1 over x. Okay, square root of 2 minus 1 equals to 1 over x. Here we will multiply this equation by x, and we get that x times square root of 2 minus 1 equals to 1. We divide this equation by square root of 2 minus 1, and we get that x equals to 1 over square root of 2 minus 1. Okay, repeat again. We actually found out that x equals to 1 minus square root of 2 minus 1. here we'll multiply this expression by square root of 2 plus 1, and then we divide it by square root of 2 plus 1, so we change nothing. So x equals to the square root of 2 plus 1 over square root of 2 minus 1 times square root of 2 plus 1, according to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. We get that square root of 2 minus 1 times square root of 2 plus 1 equals to square root of 2 squared, that is 2, minus 1 squared, that is minus 1. So x equals to the square root of 2 plus 1 over 1. So in conclusion, we found out that x equals to either square root of 2 plus 1 units, or in terms of numbers, x equals to 2.414 units. This again. X is also BC. Line segment BC that is equal to x is equals to either square root of 2 plus 1 units, or in terms of numbers, is equals to 2.414 units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment BC is equal to x. So in the drawing, we have two quarter circles, and those two quarter circles are tangent to each other at this point, point B. In addition, we know that line segment PS equals to line segment QS. We also know that line segment AB equals to 1 unit in its length. Again, our mission is to find out the length of this line segment BC that is equal to x. Okay, so because of the fact that this is a quarter circle, so this again equals to 90 degrees, and PA and AB, they are both the radii of this quarter circle. But PA equals to 1, therefore, again, PA and AB, they are both the radii of the circle, but PA equals to 1, then therefore AB must be also equal to 1. Likewise, in the big quarter circle QCB, QC and BC, they are both the radii of this quarter circle, but we know that QC equals to x, therefore we know that BC equals to x, therefore QC must be equal to x. Okay, then I copied the right triangle PAB in the new page and implemented the Pythagoras theorem in this right triangle PAB. this is the right triangle PAB that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle PAB, PB square equals to PA square plus AB square. So PB square, that is the square of the hypotenuse, equals to PA square. PA is 1, therefore PA square is 1 square, that is 1, plus AB square. AB is 1, so AB square is 1 square, that is 1. So in total, PB square equals to 1 plus 1, that is 2. PB square equals to 2, we took out of this equation and finally found out that PB, the hypotenuse PB, the length of the hypotenuse PB equals to the square root of 2 units. Okay? Then, we know that in the right triangle PAB, side PA equals to side AB. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, there are two equal angles. So those two angles that are located in front, the equal sides must be also equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha. And we also know that the sum of the angles in any triangle is equal to 180 degrees, and especially is true in triangle PAB. So the sum of the angles in triangle PAB is alpha plus alpha, that is 2 alpha plus 90 degrees. In total, they must be equal to 180 degrees. We subtracted 90 degrees from this equation, and finally we found out that 2 alpha equals to 180 degrees minus 90 degrees, that is 90 degrees. Here we divided this equation by 2, and finally we found out that alpha equals to 90 degrees over 2, that is 45 degrees. So those two angles are both equal to 45 degrees in their sizes. So we can write here that this angle equals to 90 degrees, and this angle also equals to 90. This angle equals to 45 degrees, and this angle also equals to 45 degrees in its size. Okay. And in the right triangle QCB, those two angles also must be equal to 45 degrees in their sizes. Why? Because side QC equals to side CB, they are both the radii of this quarter circle. And we know that in front of equal sides there are equal angles, so those two angles must be equal to each other. So we can repeat on the same process, and we will conclude that each of those two angles are equal to 45 degrees in its size. So then I copied the right triangle QCB in the new page and implemented the Pythagoras theorem on this right triangle QCB. This is the right triangle QCB that I copied from the original drawing. In the right triangle QCB, QB square equals to BC square plus QC square. Again, QB square equals to QC square plus BC square. So QB square, that is the square of the hypotenuse, equals to QC square. QC is x, therefore QC square is x square plus BC square. BC is also x, so BC square is x square. So in total, QB square, the square of the hypotenuse, equals to x square plus x square, that is 2x. So QB square equals to 2x. We took out of this equation and finally found out that QB equals to the square root of 2x square. The square root of x square is x, so inside the root we left only with 2. So in conclusion, we found out that QB, that is the length of the hypotenuse of the right triangle QBC, it is equals to square root of 2 times x. Here, QB equals to the square root of 2 times x, and we already found out that the hypotenuse PB of the right triangle PAB equals to the square root of 2 units. So then I presented to you rule number 3, we implemented rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So here in the drawing we have the straight line AB. If you focus on the upper side of the straight line AB at point Q, the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point B, which angles we have at the upper side of AB at point Q, we have this angle alpha and angle beta. So in total, alpha plus beta must be equal to 180 degrees according to this rule number 3. We actually can implement rule number 3 in our drawing. Why? Because if we focus on the upper side of the straight line AC at point B, here the sum of the angles must be equal to 180 degrees according to rule number 3. So I copied the straight line AC here, and which angles we have at the upper side of AC at point B. We have this angle that is equal to 90 degrees, plus the missing angle, plus this angle that is also equal to 45 degrees. In total, the sum of those three angles must be equal to 180 degrees according to rule number 3. Repeat again, 45 degrees plus the missing angle that we define as x, plus this angle is equal to 45 degrees. In total, they must be equal to 180 degrees according to rule number 3. So here we have 45 degrees plus 45 degrees is 90 degrees. So in total, on this side of the equation, we have 90 degrees plus x that is equal to 180 degrees. Here we subtract 90 degrees from this equation, and finally found out that x equals to 180 degrees minus 90 degrees, that is 90 degrees. So the missing angle must be equal to 90 degrees. X equals to 90 degrees. So we can write here that in the original drawing, that the missing angle PBQ, this is the missing angle PBQ, that is equal to 90 degrees in its size. Then I blocked the right triangle PBQ by a circle. We have a rule that any triangle can be blocked by a circle, and especially the right triangle PBQ. So actually, this is the right triangle PBQ that I blocked by a circle. And again, we just right now found out that this angle PBQ equals to 90 degrees in its size. So in the drawing we have peripheral angle PBQ that is equal to 90 degrees in its size. And we have rule number 5 that relates to any peripheral angle that is equal to 90 degrees in its size. We have rule number 5 that says that any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have peripheral angle MAN that is equal to 90 degrees in its size. And therefore, according to this rule number 5, this peripheral angle MAN must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle MAN rests on chord MN, and indeed chord MN is the diameter of the circle. Why? Because chord MN passes through point O, that is the center of the circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. So in conclusion, you can say that because of the fact that peripheral angle MAN equals to 90 degrees in its size, it rests on the diameter of the circle. MN is the diameter of the circle. So we can actually implement rule number 5 in our drawing. Why? Because we know that peripheral angle PBQ equals to 90 degrees in its size. Therefore, according to rule number 5, this peripheral angle PBQ rests on the diameter of the circle. That is to say, PQ is the diameter of the circle. So, if we define the radius of this circle as r, then the diameter PQ must be equal to 2r. Okay? So, here PQ equals to 2r from one side, but from the other side, we know that PS equals to SQ. So if PS is x, then SQ must be also equal to x. Okay, so PQ in total must be equal to x plus 2x. PQ in total must be equal to x plus x, that is 2x. Again, from one side, PQ is the diameter of the circle that is equal to 2r, and according to what is given us in the question, QP must be equal to 2x. From those two equations, we derive that 2r equals to 2x. We divided this equation by 2 and finally found out that x equals to r. So here, that is to say, PS is the radius of the circle, and SQ is also the radius of the circle, that is equal to R. Then we join points here. At point S, the two radii touch each other. Therefore, point S must be the center of the circle. Then we join points S and B together by a straight line. Point S is the center of the circle, point B is the point of the circle itself, therefore SB is the radius of the circle, that is equal to R. You can write down that SB is the radius of the circle, that is equal to R. Again, we join points S and B together by a straight line. SB is the radius of the circle, that is equal to R. So actually, PS, SB, and SQ, they are all the radii of the circle, that is equal to R. In the next step, we completed the big quarter circle to a circle. We completed the big quarter circle QCB to a circle. So actually, this is the quarter circle that we completed to a circle. Here we know that QS equals to SB. QS is the radii, is the radius of the previous circle, and it is equals to SB, that is also the radius of the previous circle. So QS equals to SB, and we have rule number 13. According to rule number 13, a central angle is twice as large as the peripheral angle subtended on the same arc. So we have a circle. Inside this circle we have peripheral angle ACB. This peripheral angle ACB subtends on arc AB. And we have central angle AOB that subtends on the same arc AB. Again, peripheral angle ACB and the central angle AOB, they are both subtend on the same arc AB. And according to this rule number 13, the peripheral angle AOB that subtend on the same arc as the peripheral angle ACB must be twice as large as the peripheral angle ACB. So if peripheral angle ACB equals to theta, then the central angle AOB that subtend on the same arc AB must be equal to 2 theta. You can actually implement rule number 13 in our drawing. Why? Because in our drawing we have the central angle QCB that's equal to 360 degrees minus 90 degrees, it is 270 degrees. So this central angle QCB equals to 270 degrees in its size according to rule number 6. According to rule number 6, the sum of the angles around a point will always add up to 360 degrees. Here we have point A. According to this rule number 6, the sum of the angles around point A must be equal to 360 degrees. Why? Because we can prove it easily if we draw a straight line through point A. Then, according to rule number 3, the sum of the angles on the upper side of this straight line is point A must be equal to 180 degrees from one side. But from the other side, according to the same rule number 3, the sum of the angles in the lower side of this straight line is point A must be equal to 180 degrees. So in total, the sum of the angles around point A is 180 degrees plus 180 degrees, that is 360 degrees. Exactly according to rule number 6. So we can actually implement rule number 6 in our drawing. Why? Because in our drawing, if we focus at point C, according to rule number 6, the sum of the angles around point C must be equal to 360 degrees. So which angles we have around point C? We have this angle is equal to 90 degrees. So the missing angle must be equal to 360 degrees minus 90 degrees according to rule number 6. That is to say, this is the missing angle that is equal to 360 degrees minus 90 degrees, that is 270 degrees. So this is the missing angle that is equal to 270 degrees in its size. So we have central angle BCQ that is equal to 270 degrees in its size. And this central angle BCQ subtends on the big chord called BQ. It subtends on the big arc BQ. Again, the central angle BCQ that is equal to 270 degrees is subtends on arc BQ. So the peripheral angle QSB, this is the peripheral angle QSB that subtends on the same arc BQ. Again, peripheral angle QSB, this is the peripheral angle QSB that subtends on the same arc BQ. So according to rule number 13, the peripheral angle QSB that subtends on the same arc BQ must be half of the size of the central angle QCB that subtends on the same arc BQ. And because of the fact that the central angle QCB equals to 270 degrees, so peripheral angle QSB that subtends on the same arc BQ must be equal to 270 degrees over 2. This is 135 degrees. So this peripheral angle QSB equals to 135 degrees. And we have already found out that those two sides are equal to each other. They are both the radii of the previous circle. Therefore they are equal to each other. So in triangle QSB, those two sides are equal to each other, and we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha. And we also know that the sum of the angles in the triangle QSB must be equal to 180 degrees. So here 135 degrees plus alpha must be equal to 180 degrees. So 135 degrees plus 2 alpha equals to 180 degrees. We subtracted 135 degrees from this equation, and finally we found out that 2 alpha equals to 180 degrees plus 135 degrees, it is 45 degrees. So 2 alpha equals to 45 degrees. We divided this equation by 2, and finally found out that alpha equals to 45 degrees over 2. So this is the angle alpha that is equal to 45 degrees over 2, and this is also angle alpha that is equal to 45 degrees over 2. Okay. Then I copied the right triangle QPB in a new page, and analyze this right triangle QPB. Actually, this is the right triangle PQB that I copied from the original drawing. We have only found out that PB equals to the square root of 2 units. The square root of 2 units here. PB equals to the square root of 2 units, and BQ equals to square root of 2 times x. Okay. And we just right now found out that this is angle alpha that equals to 45 degrees over 2. So in this right triangle PQB, tangents 45 degrees over 2 equals to PB over QB. Tangents 45 degrees over 2 equals to PB over QB. So PB is square root of 2 and QB is square root of 2 times x. So we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 gets cancelled. And finally we found out that tangents 45 degrees over 2 equals to 1 over x. Again, according to equation number 1, tangents 45 degrees over 2 equals to 1 over x. This is from one side, but from the other side, we have the trigonometric identity that tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. We defined theta as 45 degrees over 2, therefore 2 theta must be equal to 45 degrees. Okay, now you can substitute theta in this trigonometric identity by 45 degrees over 2 and 2 theta by 45 degrees. We did it, and we got that tangents 2 theta is 45 degrees, so it is tangents 45 degrees, that is equal to 2 tangents theta. So it is 2 times tangents theta. And theta is 45 degrees over 2 over 1 minus tangents square theta. So it is over 1 minus tangents square theta, and theta is 45 degrees over 2. Okay, so in conclusion, found out that according to equation number 2, tangents 45 degrees equals to 2 times tangents 45 degrees over 2 over 1 minus tangents square 45 degrees over 2. And tangents 45 degrees is 1. Again, tangents 45 degrees is 1. And then we defined tangents 45 degrees over 2 is t. So we have here times 45 degrees is 1. That is equals to 2 times 45 degrees over 2. And times 45 degrees over 2 is t. So we can substitute times 45 degrees by t. So in the numerator we have here 2t over 1 minus tangent square 45 degrees over 2. If tangent 45 degrees over 2 is t, then tangent squared 45 degrees over 2 is t squared. So in total, in the denominator we have 1 minus t squared. Okay. The denominator we have 1 minus t squared. So in conclusion, found out that according to equation number 1 equals to 2t over 1 minus t squared. Here we multiply this equation number 2 by 1 minus t squared, and found out that 1 minus t squared equals to 2t. Then we added t squared to this equation number 2, and finally found out that 1 equals to 2t plus t squared. We subtracted 1 from this equation, and finally found out that t squared plus 2t minus 1 equals to 0. So this is a quadratic equation. The coefficients of this quadratic equation are as follows: a equals to 1, b equals to 2, and c equals to minus 1. And the variable that we are looking for in this quadratic equation is t. So x equals to t, and the general solution for a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our case, x equals to t, so substitute x by t. So t equals to minus b. b is 2, therefore minus b is minus 2, plus minus square root of b squared. b is 2, so b squared is 2 squared, that is 4. Minus 4 times a is 1, times c, that is minus 1, over 2a. a is 1, so 2 times 1. So inside the root we have 4 minus 4 times minus 1 is plus 4. So in total, inside the root we have 4 plus 4, that is 8 over 2. So 2 equals to minus 2 plus minus square root of 8 over 2. Then t equals to minus 2 plus minus, and 8 is 4 times 2 over 2. The square root of 4 is 2, so inside the root we left only with 2. So in conclusion, found out that t equals to minus 2 plus minus 2 times square root of 2 over 2. 2 over 2, minus 2 over 2 is minus 1, and 2 over 2 is 1. So in conclusion, found out that t equals to minus 1 plus minus square root of 2. So we have two solutions that are possible for t. The first solution for t is that t equals to minus 1 minus 2. According to our definition, t equals to 45 degrees, 45 over 2. T equals to tangent 45 over 2. But tangent 45 over 2 is a positive number, and it cannot be equal to this expression that is a negative number, so we cancel the solution, and we left only with the second solution that is possible for t, that t equals to minus 2, that t equals to minus 1 plus square root of 2. According to our definition, t is tangent 45 over 2, so t that is tangent 45 over 2 equals to square root of 2 minus 1. So tangent, this is according to equation number 2, but according to equation number 1, we have found out that tangent 45 over 2 equals to 1 over x. So from these two equations 1 and 2, we derive that 1 over x equals to square root of t, 1 over x equals to square root of 2 minus 1. Then we multiply this equation by x, and found out that x times square root of 2 minus 1 equals to 1. We divided this equation by square root of 2 minus 1, and finally found out that x equals to 1 over square root of 2 minus 1. Again, x equals to 1 over square root of 2 minus 1. Then we multiplied this expression by square root of 2 plus 1, and then we divided by square root of 2 plus 1, so we change nothing. So x equals to square root of 2 plus 1 over square root of 2 minus 1 times square root of 2 plus 1. according to the algebraic identity that a plus b times a minus b equals to a square minus b square, it will be equal to 2 minus 1, that is 1. So we found out that x equals to square root of 2 plus 1 units, or in terms of numbers, x, that is bc, it is equals to 2.414 units. I repeat again, the length of this 97 bc it is equal to x. It is equals to either square root of 2 plus 1 units, or in terms of numbers, x equals to 2.414 units. Okay, thank you very much.